And live. Okay, so what questions did you guys have on the prep? Or did we just want to go through and answer all of them together? To make sure we're all the same anyway.
Well, might as well, because that's the quiz. It's just another quiz.
Right.
All right. Well, number 1. Given a 90% confidence interval of 45 to 105 for mean heart rate, which of the following is the best interpretation of this confidence interval? A. You're 90% confident that the true mean heart rate is between 45 and 105. B. There's a 90% chance that the true mean heart rate is between 45 and 105. C. 90% of all people have a heart rate between 45 and 105. And D. There is a 90% chance that the sample mean heart rate is between 45 and 105. I put B.
Yeah. I think I did too. Let's see, let's check. B is, sorry, I'm still pulling it up.
Oh, you're fine.
Yeah. But I think I answered B, but we'll find out when it comes up.
Yeah. Yeah, B.
B? Okay. So, number 2, I guess. Researchers at the University of Mississippi wanted to determine whether the reaction time in seconds to no-go stimulus of males differed from that of females. The researchers randomly selected 20 females and 15 males to participate. The go-no-go stimulus required the student to respond to a particular stimulus and not to respond to the other stimuli. Use this information to answer questions 2 and 3. So number 2, the researchers decided to construct a confidence interval to determine if the difference of the means is significant. To determine whether the confidence interval would be reliable, they created QQ plots of both random samples and see that they are approximately normal. Are the requirements for constructing a confidence interval satisfied? Why or why not? I put B for this one as well, which was yes, the distribution of the mean of each sample is normal since the data has been determined to be normal.
Yeah, that's what I put too.
I got that too.
Okay. And then number 3 is what kind of confidence interval is appropriate for this experiment. I put B, the confidence interval for the difference of means of independent samples.
Yep.
Well, I guess I can read that now. Since the researcher is interested in estimating the savings account balance of customers of our bank, she obtains the savings account balance of a random sample of 40 customers, a 95% confidence interval for the mean. The savings account balance of bank customers found to be $3,402.08 and $4,142.75. Which of the following would produce a confidence interval with a small margin of error in this 95% confidence interval? Okay. Before I put C.
Yeah, that would make sense.
Because all the other ones, I don't know. What do you guys think?
I put B originally, but I think changing the N would change the margin of error.
So we're going with C?
Yeah, C makes sense to me.
Yeah.
Because the confidence interval, that's just telling you we want it within a smaller, just a smaller margin of error rather than
You still have a 95% chance of being, 5% chance of being wrong with the 90 extension.
Yeah.
Okay.
Number 5. Okay, so a factory makes propeller drive shafts for her ships. A quality assurance engineer at the factory needs to estimate the true mean length of the shafts. He randomly selects 4 drive shafts made at the factory, measures their lengths, and finds their sample mean to be 1,000 millimeters. The lengths are known to follow a normal distribution whose standard deviation is 2 millimeters. Calculate a 95% confidence interval for the true mean length of the shafts. That's when I'm going to say
Why?
And this is when you plug it into the one sample t-test thing or the quantitative inference procedures, and it should give you the confidence interval of 997.9 to 1002.099. Which is
What'd you give?
well, what kind of test would that be? Would that be greater than, less than, or not equal to?
It would be just make sure mean length and turn the 4%.
I would say not equal to.
Yeah, that's what I was thinking too.
Okay, well in that case it should be 996.818 to 1003.182. This, again, is not an answer.
So what was the answer? I'm sorry. Just so I can make sure I got it.
Well, that's why I'm confused, is because I typed it into the quantitative inference procedures worksheet, and the answer popped up there is not one of the answers.
Oh, yeah.
The closest answer on there is B.
Right. And how many? Let's see. Did you put for the sample N? Did you put 4?
Yeah.
You did. Okay.
Yeah.
It's 818. Oh yeah. Yeah, that software. Right. That's weird.
Yes.
The answer's not there?
No.
I mean, maybe if we change the null hypothesis to 1,000.
Isn't the null supposed to be 2?
The null hypothesis?
If you change it to, it's the same thing. I just put it at 1,000 and I still got.
Yeah, I got the same thing too.
Yeah.
I say we go with B because it's the closest answer.
Yeah.
I agree. Yeah.
All right.
Okay. So this is the actual one for skills. Let's see. Unknown mean. The mean is unknown.
Yeah.
Yeah. Off.
Because the sample size formula is n equals the z-score times theta over m, all of that times 2, or squared, but I don't remember what m is. Or is m the margin of error? Oh, wait, the standard weight that is known to weigh 1 gram is repeatedly weighed a total of n times. So the sample mean, no, the standard weight is 1 gram, so I feel like that has something to play with this.
Okay. You guys figured it out yet?
Nope, I am completely lost. I don't know how to
Me plugging in, I'm
do
getting 2
what?
answers that come out with the same 0.001. Which kind of confuses me.
How are you, what formula are you using?
I'm just plugging it in. Under the 1 sample 2
To what,
test
though?
remains. The 1 sample 2 test remains.
But we don't have a mean for it, that's the thing. We can't.
Well, I just assumed that it was 1.
And well, it's the thing, though, is the mean, it says that we have an unknown mean. The standard weight is 1, but we don't have a known mean.
Yeah.
Let me see if I can find the notes for this. Um, well, how about we skip this question and come back, because my computer's taking forever to load that.
Okay.
So number 7. The mean area mu of several thousand apartments in a new development is advertised to be
Okay.
1,250 square feet. A tenant group thinks the apartments are smaller than advertised. They hire an engineer to measure a random sample of apartments to test their suspicion. The appropriate null and alternative hypotheses for mu are, well, mu would be 1250, and they said they think they're smaller, so then the alternative would be that they think the mu is less than 1250.
Yeah.
So A.
Yep.
Yeah.
Okay.
Number 8. It says in a statistical test of hypothesis, we say the test result is statistically significant, the level of significance. If
B.
The p-value is statistically significant at the level of significance. Well, if it's at the level of significance, wouldn't it be A?
yeah, I would think so.
Oh yeah.
Because that's what you're running at.
Statistically significant at the level.
That's the level of significance, so I'll go with that.
No, because A is just telling us what the level of significance is.
Yeah,
Just kidding.
that would make
It should
sense.
be D.
D?
It is D.
I'm pretty sure.
Yeah.
9, it says a group
With
is.
that too.
We good? So number 9, a group of statistics students want to determine if students in some apartment buildings get better grades than students in other apartment buildings. They collect GPAs from an anonymous random sample of size 15 from each of 4 different apartment buildings. The data for each apartment building are bell-shaped with no outer liars, and the sample standard deviations are nearly equal. Can they use an ANOVA hypothesis to answer their question? For a 9, I put
I
A.
say A.
Yeah, that's what I put.
Yeah, it's like
Because they tested the amount of data they have.
groups. Okay.
Yeah, okay. Yeah.
Yeah, A. Number 10. A medical researcher is working on a new treatment for a certain type of cancer. The average survival time after diagnosis for the standard treatment is 2 years. So the null hypothesis is that average survival time after diagnosis is the same for the new treatment and the standard treatment. In an early trial, she tries the new treatment on 3 subjects. who have an average survival time after diagnosis of 4.5 years. Even though the sample is small, the null hypothesis would be rejected at the 0.05 significance level. Consequently, she rejects the null hypothesis. In a future study, it is determined that the new treatment does not increase the mean survival time in the population of all patients with this particular type of cancer. The researcher has different types of error.
I put A in the chat.
There's a new treatment.
I want to say it's a type 2 error because it's
Type 1
committing.
error,
That
maybe?
is when you fail to reject the null hypothesis that is in reality not true.
So, reject them.
Yeah, it would be B for type 2.
Do you think it's B?
Yeah, I'm pretty sure.
Yeah.
Okay.
I
That one I should study. What a type 2 error is.
Because a type 1 is rejecting the null hypothesis when it really is true, and a type 2 is failing to reject the null that is not true.
Yeah.
Right.
Wait, she did reject the null.
Yeah, she rejected
And then
it. And she rejected it again the second time.
Because it says a type 1 error is committed when we reject a null hypothesis that is in reality true. A type 2 error is committed when we fail to reject a null hypothesis that is in reality not true. The value of A is the probability of committing a type 1 error. So let's see. So the null hypothesis would be rejected at the level of significance. So she did reject the null, and found out through a future study that the doesn't. Because when she rejected the null, she was saying that it did have an effect on the cancer patients, and in the new study, it showed that the mean survival time of the population of all the patients with that type of cancer does not increase. So it would be a type 1 error, not a type 2 error. Sorry, guys.
10?
It should be type 1 because she rejected the null when she should have failed to reject the null.
Okay. Yeah, I just guessed on that one, so yeah, you're good.
So I found the sample size formula for number 7. Or for number 6. And so it's n equals t-score times the standard of error.
Which number are we on?
I was jumping back to number 6 because I found the formula.
Oh, okay.
And so 0.95 times 0.01 divided by 0.001.
Why are you telling me about 0.91?
Because it says the margin of error gives an estimate of the variability of responses. It is calculated, and it gives me the the formula, it says where z-score represents the calculated z-score corresponding to a particular confidence level. And so since we don't have a z-score because we don't have a mu to calculate it with, you just use the z-score, or the confidence level, wouldn't you?
Yes. But
That's the only thing I can
the
think of.
0.9, you said 0.91 too, right? Or is it the 0.01? I'm confused on what happened there.
Only problem is I'm not getting any of these answers when I use that formula. Unless we're supposed to use the 1 to find our z-score. But we still don't have a mu, so I don't know how you would find that.
Oh,
Did you guys figure anything out for number 6? Because I'm lost.
I really don't know. I'm trying to I'm trying to figure out how to do it. Um,
Yeah, I have absolutely no idea how to do number 6.
I don't either.
I'm going to assume, though, that with such a high margin of error, or I guess with such a low margin of error, it's going to have to be a high number.
Yeah, I kind of wrote that it wasn't A. Just by like
You thought A?
No, I thought it wouldn't be that one.
Yeah. I'm almost curious to see if maybe I can work it backwards from one of those numbers.
I've been trying to do that. I haven't had much fun.
My only problem is when you solve it backwards, the only thing we're going to get the answer for is the z-score, and we don't have a z-score to compare it to.
Yeah.
Unless we're finding where the z-score should be 1.
What are you actually trying to solve for? Just figure out how you're trying to run it through.
Well, the thing is, I'm just solving for the z-score and seeing which z-score I guess would be closest to 1. It looks like the closest one to giving us a z-score of 1 was B.
Yeah.
Because that one was 1.139. And then A was 0.442, C was 1.96, and D was 2.132.
Okay.
So I'm good with guessing B.
Yeah, well, that's what I guessed in the first place. So I'll go with that. I guess we lost Cameron again.
We did?
Yeah, he's not there.
Oh. Let me see if I can add him back on again.
It says, yeah, you lost connection 4 minutes ago.
Did he message you?
Well, he messaged, I guess, all of us. It was kind of like a group
Okay.
chat thing.
Yeah. I'm really bad about seeing where those are, so... Lost connection.
He's been having problems. He's come and gone like 3 different times.
Hey, back on.
Okay, cool.
Yeah.
We were on number
I'm
11,
going
right?
to buy a whip, and I'm going to flog my computer to death. So
That
so
sounds
y'all
like
know.
fun. You can join me when I shoot my giant TV with a shotgun. I want it playing bigger better. I didn't actually spend money on the TV.
Nice.
It's about 15 years old, and it weighs like 100 pounds, so I feel like it's an okay thing to do.
Yeah. Oh, yeah. Oh, it is.
Anyways, so for number 6, we decided we were going to guess B.
Okay, so we're on number 11, right?
Yeah.
Okay. So for 11, it says that the level of significance is made very small, thereby making the probability of committing a type 1 error very small. What happens to the probability of committing a type 2 error?
Wouldn't it increase?
I think so.
Yeah, I put D, yeah.
That's what I put too.
It is the opposite. Okay, so number 12. The nicotine content in cigarettes of a certain brand is normally distributed, which means in milligrams. Now the mu and the known standard deviation of 0.17. The brand advertises that the mean nicotine content of its cigarettes is 1.5. but measurements on a random sample of 100 cigarettes of each brand give a sample mean of 1.53. Is this evidence that the mean nicotine content is actually higher than advertised? To answer this, test the hypothesis.
Wait, what?
Number
Okay.
12.
Use that hypothesis. So I feel like we should just put everything in the testing thing and see what it pops out for us.
Mhm. All right.
With that one, the p-value that I got was 0.0403.
Let's see. Um, okay, sorry. What the hell? This for, let's see. Is this just a one sample test or is it something else?
Yeah, it's just one sample.
Okay. Yeah, what did you, let's see. What did you get for your p-value?
I got 0.0403.
All right, yeah, I'm way off. Okay, so I put, okay, so for the
For the mean, did you put in 1.5 or 1.53?
1.53.
Yeah, and then the standard deviation is 0.17,
0.17, yeah.
and then n is 100.
Yep.
The confidence level is 0.95.
Yeah. Oh, okay, I think I
And
just,
then the null hypothesis was 1.5.
okay, yeah. I just put that in.
And that should be a greater than 10.
Yeah, so I got 0.0403, yeah. Okay, yeah, sweet. So then we would,
So we should reject the null, right?
Yeah.
wait, the p-value, yeah. P-value is low, yeah, I think you reject the null, right? It's lower
Yeah,
than,
you reject it if it's less than the significance level, and you fail to reject if it's higher than the significance level.
yeah.
Right?
Yeah, if it's p-value is low, then you reject the null. Good, man. Yeah, online class stuff, yeah. See you, man.
Okay, so for 12 we went with A, right?
Do what?
For 12 we went with A, reject it.
That's the alternative. You want to D, reject the null.
Oh, my bad.
Reject the null.
So D. And then 13. We'd like to look at the mean number of hours worked for wages per week by male students and female students. You would like a random sample of 100 for each group and test if those means are different. What is the correct statistical procedure? Wouldn't you do an independent samples test?
My male.
I'll do a what?
Male students really good.
Independent samples test?
Independent sample set test? Yeah, I think. Yeah.
Because the male students and the female students working don't affect each other, so it's not a matched pairs test.
Yeah. Okay.
So then, number 14, an educator is interested in academic achievement by males and females with similar academic support systems. He decides to use brothers and sisters raised in the same home. Furthermore, she decides only brother-sister pairs when they are not next to each other in sibling order. Should she use a hypothesis test based on independent or dependent sampling? That's hard.
Maybe dependent, just because they're testing whether, like, you know, she decides to use
If
brothers
you select a
and
brother,
sisters
there's academic achievement test.
raised.
I would say D.
That's what I probably. I don't know the answer.
Yeah, D.
Okay, cool. We're going to need to open the dissolved organic carbon file. But the scenario behind this is that a soil scientist collected random soil samples from a field and measured the dissolved organic carbon level of each sample. Dissolved organic carbon molecules are an important part of an ecosystem and help us to process organic compounds. The researcher would like to construct a 95% confidence interval for the mean dissolved organic carbon level in the field. Use the data file dissolved organic carbon, and then use this information to answer question 15 and 16. So it looks like there's just one column of information.
Yeah.
And so we'd want to make a confidence interval for when the standard deviation is unknown. Because there's not two different samples, so we couldn't do the difference of mean.
Yeah.
And it doesn't give us the standard deviation, so for when sigma is unknown, so B.
Yeah.
So then 16 was, which of the following is the 95% confidence interval for this data? And I got 11.168 to 15.217.
Okay. So wait, what did you get? 11.1?
168 to 15.217.
Yeah, that's what I got. So that'd be D.
Yeah.
Yeah, we lost Cameron again.
We did?
Yeah,
Oh my goodness.
His internet's not that good.
It still says he's on the call.
Like that? Oh, no, he's still there. I don't know. I was looking on the side. Yeah, he's still there, I think. Maybe. Oh, yeah. Okay. So let's go for next one. What was this one
Cameron?
called again?
You there?
I forgot which one I was looking at. Use context.
Alright, well, looks like the next file we're going to have to open is the used Tummers LA in New York.
Yeah. For some reason I'm having problems opening it right now.
What I did the other day was there's when you open up that top file thing, you can just open it to where there's where it says like the zip file for all of them. So I downloaded the zip file, so now I don't have to download them anymore. Now you just click and they open.
Yeah, but for some reason I don't think this is an Excel sheet because it's asking me what I want to open it with. That's my problem.
Well, the link on the Word doc or on the page should just take you to the pages that has all that stuff.
Yeah, but it's not. That's my problem.
Because it opened an Excel document for me when I opened the worksheet.
Yeah, it's not right.
Alright, well, it looks like we're making another confidence interval for it, so let's see. A random sample of Hummers for sale in Los Angeles and New York were taken from listings at Cars.com. We want to know if there's a difference in mean listing prices between Hummers for sale in Los Angeles and Hummers for sale in New York. Create a 95% confidence interval for the true difference of mean listing prices between the two cities. And then number 17, it just says, of the 4 types of confidence intervals listed below, which one is appropriate for this situation? It should be D, because the sale price in LA should not affect the sale price in New York.
Okay, okay. So you put D?
Yeah.
Yeah, that's what I put.
Okay. We're using the sale price, right?
What?
Okay. So we're using the sale price, right? I have to make sure I'm copying down the right information into the right section.
I'm still trying to open it. I don't know why this one's giving me problems. No. Yeah, I can't figure out how to open this.
That's okay, I can copy and paste it in.
Okay.
95% confidence interval. Difference mean this between numbers. So since we want just to see if the means are different, would I do a not equal to type of test?
No. Yes. Because I don't see why you picked any of the other two.
Yeah, I don't either. That's why I was double checking. But it looks like the confidence interval there is negative 423 to 5417.
That's C.
Holy crap! How many of these stupid things do we have to open?
Okay. Wait, what?
Bone density is the next one we have to open.
Okay. This one should open. Is it bone mineral data? Is that what you mean?
No, exercised bone density.
Exercise. Bone density.
Cameron, are you there?
My computer's having a fit. It's not opening this one in Excel either. Oh gosh.
Oh, it kicked Cameron off again.
There we go. Well, we can answer 19 first.
Yeah.
What is the correct hypothesis for situation?
I'm trying to get Cameron back in the call real quick.
Okay.
Your computer's just giving you lots of trouble today, isn't it?
It is. So much trouble. Unbelievable.
What was the last answer that you heard that we went over?
As we're going over the Hummers and
Okay.
Los Angeles, New York.
You get 17? Okay, and then we got C for 18.
See for 18. Now when you do, you don't.
It was the 2-sample t-test because it's independent samples. At least I'm pretty sure it is. Unless we're supposed to find the confidence interval of the mean, the difference.
Prices.
Oh, dang it. It was a paired sample t-test, not 2-sample. Let me fix that.
Okay.
The confidence interval should be -649 to 7279. No, just kidding. That's not an answer. So it is a 2-sample t-test.
It is 2-sample?
Yeah, it's a 2-sample t-test because it's independent. So I just put it in the paired sample t-test, and that one didn't do anything. Yeah. So 18 should still be C. Alright, so remember the study for 19. Says many studies have suggested that there is a link between exercise and healthy bones. Exercise stresses the bones, and this causes them to get stronger. One study examined the effect of jumping on the bone density of growing rats. There were three groups of rats. Rats selected at random for the three groups: a control group with no jumping, a low jump group where the jump height was 30 centimeters, and a high jump group, which is 60 centimeters. After 8 weeks of 10 jumps per day, 5 days per week, the bone density of the rats was measured. The rats were selected at random from the three groups. Researchers would like to perform a hypothesis test to determine if the mean levels of bone density are different between the three different groups of rats listed above. Use a significance level of 0.05, and then use the data in exercise bone density file. 19 is, what is the correct hypothesis test for the situation? It should be ANOVA because there's three groups. Does that make sense?
Yeah.
Okay, I was making sure. And then we need to find the test statistic for number 20. And it looks like we're using this thing for 2019 through 22. So it looks like test statistic for the F score is 7.978.
Yeah.
Okay. Did you get the file open?
Yeah, I got the file open.
Okay, cool. Do you have it open too, Cameron? What did you get for the p-value? I got 0.002.
Yeah, because you had to round it from the 0.118 or whatever it was. Yeah, you had to round it.
Yeah. Okay.
So 22. This is basically. Would it be D? But it's pretty obvious that there's huge differences.
Well, since it is less than the significance level, we would fail to reject the null, right?
Yeah.
So that would say that there is sufficient evidence that the groups, that one of the groups would be different, wouldn't it?
Yeah. Would it just be B? I was thinking in D, which is like, is it just one or is it all?
It would be at least one.
Okay.
Because all of the groups we'd have to go through and test between each of the groups and then compare.
Uh-huh.
But when you do the ANOVA test, it just says that at least one of the groups is different.
Okay.
Okay. So for 23, pressures of supply and demand act directly on the prices for an airline ticket. As the seats available on the plane begin to fill, airlines raise the price. If seats on a flight do not sell well, an airline may discount the ticket or even cancel the flight. A study was undertaken to determine if there was a difference in the median cost of an airline ticket purchased 90 days in advance of a scheduled flight compared with the ticket purchased 14 days in advance. Data was collected on the cost of a one-way ticket from London's Heathrow Airport to a variety of destinations in Europe. The lowest published ticket prices of one-way flights from Heathrow to various destinations was recorded for each scheduled flight 90 days in advance and then again 14 days in advance. Perform a hypothesis test to determine if there is any difference in the cost of the non-stop flights when the tickets are purchased 14 days in advance compared to 90 days in advance. Significance level is 0.1, and we're using this for the rest of the quiz.
Yeah.
So what 23 is, what is the correct hypothesis test for this situation? Wouldn't it be a matched pairs? Maybe.
Yeah, you'd have to. You'd be comparing them. So yeah.
So does matched pairs?
Yeah.
But and the samples are dependent on each other, aren't they? Because the study was undertaken to determine if there is a difference in the mean cost of an airline ticket purchased 90 days in advance compared with the purchase of only 14 days in advance.
Yeah.
And then it says, perform a hypothesis test to determine if there is a difference in the cost of the non-stop flights when the tickets are purchased 14 days in advance compared to 90 days.
Yeah.
So I feel like it would be the matched pair still.
Yeah, that's what I was thinking.
Did we lose Cameron again?
Probably. Yeah, he's gone.
There we go. Not really sure what happened. I invited him back, so hopefully he makes it back. If not, I guess we'll have to email him and finish with him over that way. Well,
how does that even make sense?
Do what?
Oh, nothing. I'm just trying to unlock that one.
Maybe it's not a paired test.
You don't think so?
Because when I plugged it in, it's telling me that I can't have a t-value or a p-value or a confidence interval because there's random ones that don't have flights. So I'm going to see if maybe putting it into the two-sample t-test changes it.
Oh, really?
Yeah, it works for the it works under the two-sample t-test.
Yeah?
Yeah. Is it your internet that keeps cutting out, Cameron?
Yep. It is. Oh, gosh.
Dang. Try turning off, maybe just turning off the video, but that way you have just the sound one.
Yeah, I'll try that.
All right.
Okay. So, Jessica, have you worked through it yet?
Well, I've got everything pasted into the 2-sample t-test, and the t-value it gives me on there is not a t-value that's available. So
Mine's not. Mine's different. Mine doesn't go over to there either. Let's see.
Oh, there we go. What I did under the paired sample t-tests, I just went in and any place that said like null or like the value was not available, I just deleted where the value was, and then it gave me a t-value of 1.685, which
You're doing the 2-sample t-test or the paired?
that was under the paired because the 2-sample t-test was like 0.8.
Yeah. So you just erase all the null ones?
Yeah, that's what I did, and it seemed to work. Because I think it just needs to either have a value or not have a value, and words will mess up the thing. And then it gave the p-value of 0.4. Nope, wrong one.
Oh, I erased all the null things and still can't.
Because like I didn't put 0 or anything in for it, I just pressed delete on just the variables, not where it said that and the difference. And it gave me 1.685. Point 56.
Oh, mine's still coming up.
It's not?
No, it's not.
Are you in the paired sample or are you in the 2-sample?
I'm in paired.
Because in the paired, I copied and pasted the variables into variable 1 and 2, and then like on B16, I just erased where it said null. On A40, I erased where it said null, and then on A and B57, I just erased null, and it worked.
Yeah, I erased all the nulls, but it's still telling me.
You didn't put in a 0 or anything for it, did you?
No.
Huh, that's weird. I don't know. Because the answers I got were answers on the thing.
We can just go with that.
Okay. Because I got the test statistic of 1.685, which was A for 24. And then the p-value I got was 0.096, which was B for 25.
Okay. Then 26.
26, well, the significance level is 0.1, and 0.096 is less than 0.1, so there's sufficient evidence.
Or 6.7. Oh, which one? Oh, never mind. I was looking at something bad. My fault. Okay, so.
Okay.
So 26 would be B.
Well, if you're failing to reject the null, you're saying that there is sufficient evidence to say that there is a difference in the price
So
for the
that'd
two
be
Ds. So it should be B.
Yeah.
For 26 or 27?
26.
There's no 27.
Oh, yeah. I didn't even look to see that far.
Okay, so we're gonna take the quiz now?
Because I think, isn't the quiz just putting all of these answers in?
Yep.
Yeah, it's the same.
We have to make sure the answers are in the same order, though. That's the problem.
Yes. I just copied and pasted it over to a Word document and highlighted the answers as we went.
Got it.
Okay. So it's 2. I'll just make sure the answers in the same order. Okay, so yeah, number 2 is in the same order for me. So for number
Who's
2,
the
we got
second
there's
one?
yeah. For that one, we got
90% chance that the true mean heart rate is between 45.
Yeah. I'm pretty sure they're all in the same order, though.
I wouldn't bet on it just because I feel like
I know,
that
I'm still gonna compare it, but it'll be nice.
So 3 should be, looks like it's still B. 4 is in the same spot. I kind of wish that she would have kept it in order so it was like 1 was 1, 2 is 2, and then put at the very end of the quiz whether or not you participated in the group meeting.
It'd be a lot nicer, yeah. Okay. So, there's a lot of checking around. So, it's really complicated to make sure we put the right answers.
Okay, for number 8 on the quiz itself, I want to make sure I have the right one. You guys clicked the first answer, right?
For 8?
Yeah, on the quiz itself, not on the prep.
Oh, yeah. That's number
Where
9 on the homework.
mu is
So
12 equals 1250, and then the alternative is mu is less than 1250.
Less than 1250, right?
and less than makes it look like it's pointing towards mu and eating 1250, right?
Equals itself.
Or like it'd be letter A on the prep assignment for number 7. Right?
Yeah.
Okay. I get those symbols mixed up, so I always double check.
I'm pretty sure that, yeah, they're all in the same order on the quiz.
They are?
Yeah. I'm looking and it's all in the same order.
Okay. I just misread one of the answers on the quiz, so I was like, I don't see it.
So
Oh. I think I wrote that. For number 12 on the homework, we put D, didn't we?
Number 12 on the homework?
Yeah.
Yes, D, rejecting the null.
Okay, because I wrote something else down, and that's what I remembered as putting, so just.
for which one?
It would have been number 13 on the quiz. 13 on the quiz, but it was number 12 on the prep. It was just that it was D, rejecting the null.
Okay. So rejecting the null. Okay.
So we'll just plug them all in and we'll read over and remember that. Make sure we
That's
all
what it
put
looks
that
like, yeah.
What?
They're too complicated to read them all.
Do what?
So we're just going to compare what we put once we all plug them in.
Yeah, we can go back and compare it. I just want to make sure I get all my answers
That'd be
moved
good.
over.
Yeah, I already put all mine in, so when you guys are ready.
Yeah, almost.
I'm ready.
Okay.
I'm good.
So I'll just read them off.
Okay.
You guys ready? 2 we put B. 3 we put B.
D or B?
B.
As in boy?
Yeah.
Okay.
4 we put C.
4
5
we put C?
Hold on.
Wait.
I'm not. No, wait. We put.
I had D.
D.
D, confidence interval for the difference of means using an independent sample.
That would be number 3. Oh, yeah. Yeah, that's what I had. I just copied it over wrong.
Okay. And that's why we double check.
Yeah. So then for 5, we got C.
Uh-huh.
6, we got B.
Uh-huh.
7, we got B.
Mm-hmm.
8,
Yep.
we got A.
Yep.
9, we got D.
Yep.
10 we got A.
Mm-hmm.
11 we got A. 12 we got D.
Yep.
13 we got D. 14 we got D.
Okay.
15 we got D. 16 we got B. 17 D. 18 D. That's a lot. 19 C. 20 E.
See?
21 C. 22 B. 23 C.
Yeah, 23 is B.
Is B. Hold on, let me check.
23 is B.
Yeah. I copied it over there again.
Okay.
Okay, that's why we checked. Okay, 24 C.
Mm-hmm.
25 A.
Okay, so what's 23?
It's B.
23 is B.
Okay, so 24 C.
B. Okay.
25 A. 26 B. And 27 B.
Yep.
Okay, so we're good?
Yeah, we're good.
Okay, I'm pressing submit.
Oh, I got a couple wrong.
Yeah, it's okay.
Hey, but it's still an 82.
Yeah.
That's
I just wish we could see what the answers were so we knew what to study.
Yeah, I know, I wish you would tell us, but
It's just those first two at the beginning that we missed. It was like number 2 and number like
Yeah.
7. Oh, 6 and 7.
Yeah.
2, 5, 6, 7, and 9. Those were the only ones we missed.
just the
Yeah.
very beginning.
Okay, well, hey, I'm happy with an 82.
Yeah, that's good.
Not ecstatic, but happy.
Okay, well, see you guys later.
Yeah, see ya.